It's a pleasure to start off proceedings with Roman Bezrukavnikov, who's from the MIT and visiting the IS this year. And he's talking about towards canonical bases and the homology of symplectic resolutions. So thanks, Roman.
Thanks, Jordi. And yeah, thank you for the opportunity to give this talk and to take part in this special year. It's been a great experience so far, despite all the restrictions and the virtual nature, unfortunately, but it's still working great. Okay, so I will in some seminars during the last few weeks, well, I had a chance to present this old work on canonical basis in well, homology of Springer fibers and applications to representation theory. But what I will talk about today is a geometric context for this construction and some ideas towards further generalization. So let me start, and I'll spend much of the time in a context which will be just a little bit more general than that of those talks. So I'll start with, so let's X to Y. Be a resolution of singularities where X will be a T star of G mod P, where G is a semi-simple, let's say reductive algebraic group, and well, over an algebraically closed field. For much of the talk, we can assume it has characteristic 0. And then, we have G contains P contains B. So P is a parabolic. Or we can say more generally, X is T star G mod P times S over N. So N is in G. The Lie algebra is the unit cone. And S transversal slice to a G orbit. Oh, and Y is just a spectrum of the ring of global functions on S. So Y is the normalization of a finite covering of a nilpotent orbit. To this we can associate H2 of X, and yeah. Let's just to simplify the wording, we assume that the minor technical assumption, which holds in many cases, that if we want to be in this more general context of a transversal slice, assume that H2 of G mod P to H2 of X is an isomorphism. It holds in many, in most cases. Okay, so then we'll have this H2 of G mod P, which I will call V. It sits inside the dual carton, so H is the extra carton. And then so yeah, just a few more standard notations. So we'll take WP, the normalizer of the Levy modular Levy, and then just a standard remark that in fact, different parabolics may lead to may give resolutions of the same orbit. For example, you can take Grossmanian Kn or Grossmanian n minus Kn, and so but so to take as a record-keeping device for all these resolutions, it will be convenient to consider this geometry of certain cones in this space V. So I didn't say, sorry. So V, yeah, I didn't specify the coefficients here, but let me say that VR will be the corresponding real thing. You can just say this R. Well, Z in the classical topology. You can just express it in terms of the weight lattice. Yeah, so V is contains V comes with the configuration of hyperplanes. Just the which we'll call sigma, so just the core root hyperplanes, the ones which do not fully contain it, intersect with V. So hyperplanes. And also so these are hyperplanes passing through zero, and there is also sigma tilde if you take the affine point. And so, so if you remove the hyperplanes in sigma, so you'll get a disjoint union of cones. And then the standard observation is that to each such cone, we can assign a parabolic associated to P, which may or may not be conjugate to P. And then, so we'll write this P C, and then T star G C. It's, well, is equal in this first case, or contains XC is another resolution. Well, it may or may not be isomorphic, but I actually want to think of this resolution together with a fixed identification between H2 of that resolution and the standard vector space, which I can think of H2 of X I started from. Okay, and so now let me introduce some sort of structure incorporating various symmetries of the derived category of coherent sheaves on my X. So to do this, I will introduce the, I will consider the dual torus. So consider, as you can think of, check, which is well, the my lattice. Maybe I will introduce a notation for that. Lattice. Yeah. Lambda. So I will. Yeah. This is. GM times the lambda. And so there are two things I want to say about this. That first of all, sigma tilde defines a finite collection of codimension 1 subtori. And so let D be the union. And then sigma defines a toric compactification. Of this dual torus, where, which I will call bar, and to each point, to each cone C, I can assign a point XC in TL bar. And I don't want to spend time on this, but I will just say plus nearby homotopic point. Essentially, looking at points of my torus with real positive coordinates, I can get a canonical nearby homotopic point. And okay, so so theorem, there exists a canonical. It's kind of more for description of a structure than a statement. You know, that stands on its own. So there exists a canonical local system of categories and so I should say WL equivariant. On well, essentially on this dual torus, but with singularities on D. And we'll call the space of U. so that the stalk, its stalk, at this nearby point near xc, point of xc is identified with dB core of xc. And so variant dB core GM of xc. So yes, I should have said that all this things, all these varieties come with a canonical action of multiplicative group by dilations. There are more symmetries, but I'm particularly interested in this one, where this GM acts by dilation on T star of G of P. So GM acts on T star of G of P by dilating the fiber of cotangent bundle. So for technical reason, it's I would want it to dilate X by the square of the tautological character. And then using Jacobson-Morozov theorem, we can, choosing GM equivalent slices, we can also extend this definition to this more general setting. And and so B the monodromy, so the resulting action on K naught of GM of XC is isomorphic to the monodromy of equivariant quantum cohomology of X. So here, of course, I need to work over C for these things to be defined. So here, maybe for safety, I should assume that either X is equal to G star G mod P or P equal to B. I'm sure it's true much more generally, but I think that's the cases in the literature. So yes, maybe I should give some references. Here, A essentially amounts to is a reformulation. So for P equal to B, this is a reformulation of an action of the fact that the affine Weil group acts by symmetries on, well, acts on the derived category of coherent sheaves of the Springer resolution or its base change. Well, X. So this is my paper with Simon Riche, and it's for P not equal to B. This was done in a thesis of my student. So thesis of Doreen Borger. There is a, fortunately, she doesn't seem to be interested in writing a paper, but there is a preprint on the archive. And so comparison with for B, I mean, it proceeds by explicitly calculating. So B, yeah, just compare with the answer. I mean, with calculation. I mean, what I'm trying to say is that it's not a conceptual comparison argument, but both sides are explicitly computed. And so for P equal to B, this is a paper of Braverman, and Openkopf. And for P not equal to B, it's a thesis of Openkopf students, student Changjian Su, who fortunately published it. Okay, so yeah, so there are some interesting symmetries of the categories, but so I want to talk about how they encode the canonical basis and how they relate to representation theory. Basically, to talk about this, we will need to focus on the stocks of this local system on the compact torus inside the complex torus. And it will be convenient to work with in log coordinates. So we have the our torus, so our space actually V, which is also the algebra of still torus. Let's now kind of work with complex numbers. So it maps by the map x 2 pi I times 2 pi I x to and so so the pre-image of the complement to D is this space VC without union, with removed union of H over H sigma tilde. Of TLC with D removed. And I want to start with axiomatics of canonical basis, which at least in the case when P is equal to B, it's a reformulation of Lustig's well, conjectural definition. Conjecture meaning he stated some properties which are supposed to characterize it uniquely, almost uniquely, and conjectured the existence, and then existence was shown in my paper on Merkage. Lustig's definition of canonical basis in a K group of spring fiber. So yeah, so I just want to say that so we looked at this pre-image, so maybe we can call it U tilde. So U tilde is of course disjoint union of I, so these are alcoves. And it's acted upon by this group WP semi-double lambda. So this action is transitive if in the Borel case, not in general, and so claim there exists a unique up to a sign collection of bases of flat sections in the well, of the local system obtained from our local system of categories by decategorification L, whose fiber is K naught of Gm of X. On each alcove. So for an alcove A, I have some basis P. And so the characterization is so there are several properties, and so they are invariant under automorphism. So this is some non-surprising axiom. So and then invariant.
Roma, would you be able to clarify automorphisms of what?
Of X, well, of X with the GM action of the situation. invariant under third duality, which essentially induces the map x to minus x on this space U. And then the key axiom is, well, there are two axioms. So one is asymptotic orthonormality. Which means that we have a pairing coming from the X pairing. And asymptotic means that we have this pairing which takes value, so it takes value takes values in Z of VV inverse, where V corresponds to the tautological character of C star. So I'm taking X in the derived category for two GM equivariant sheaves. I take X in the between them as a sheaf, and the equivariant structure induces an additional grading. So I can take equivariant or the characteristic again and get a Laurent polynomial. And three, it's that these are bases permuted by half monodromies. So this is so let me say a little bit about this. So this is says something like this. So suppose we have two neighboring alphas, so A and A prime, and I can so they're separated by hyperplane H in signature, and I can connect them by a path going in the positive direction from A to A prime. And then I can actually continue working in the positive direction and go back to A. And so then this would give the monodromy, right? So so the monodromy for the loop around H, which starts and ends in A, is a well, it's some automorphism of the category, and also automorphism of the K group. So let's call it M. I claim that it has the following property. That if I order my bases in an appropriate way, so I can order the bases so that M in this basis is block upper triangular with powers of Q, with maybe plus minus powers of V on diagonals or on the diagonal. And now I take the following. In fact, here there will be even powers of V, so I call them V to the power 2di. Now, if now consider a basis formed by V, well, to the power di times ei, where ei is an element in the canonical basis attached to A, and apply well, a version of Gram-Schmidt algorithm to make it to find a basis which differs from that one by block upper triangular transformation, and which is asymptotically orthonormal. Gram-Schmidt. To make it asymptotically orthonormal. And then, so we get a new basis and we apply this half monodromy to put it into A prime. So this is the image of that semi-orthonormalized basis of under the isomorphism corresponding to this half loop. Above path connecting A to A prime is the new basis, is B A prime. So this is the end of the axioms. And the comment here is that, well, difficult part is existence, and so existence follows from my old paper with Merkovich, where it's after some reductions, it's proved using property of Frobenius weights for Prozorskis on the affine flag variety. And then, why are we interested in these things? So key point is that these are these bases are formed by classes of the basis given by the classes. By the classes of reducibles in certain non-commutative resolutions of the same space Y, which have a representation theoretic meaning in A mod, where A is a non-commutative algebra, which, well, from the from what is said already, so this is a dB of a mod is the fiber of our, is the stock of our local system. On the corresponding alpha A. And in particular, for P equal to B, the central reductions, so well, is the characteristic zero lift of the category of modular representations. Well, let's say fixed central character. So fixed central character is a characteristic zero lift of the category of the category G modules, where now G is over K of characteristic P. With also with a fixed central character, which depends on the data we've chosen before. We should pause for questions. Okay, so yeah, and then there are other representation theoretic applications, other contexts of representation theory where it appears, but let me instead talk about further features of this situation. So properties of this algebras AA. Well, and the corresponding derived equivalences. So first, I want to talk briefly about perverse equivalences and central charges. We'll recall the definition of perverse equivalence, which generalizes the relation between perverse sheaves and ordinary sheaves. So suppose we have, I guess an original reference is the paper by Shang. So suppose we have two abelian categories. So if B abelian categories and dV the derived equivalence is called a perverse equivalence if we are given it's kind of additional structure, not just a property. We have filtrations by Serre subcategories. Well, I'll write it as a decreasing. It doesn't matter so much. And also, also, I will work with self-indexing perversity. So yes, so that the corresponding filtration. So this is a function phi. The phi sends the full subcategory with cohomology in AI to the full subcategory in homology in BI, and on the induced equivalence on the subquotient is in fact exact with shift by I, and he well induces basically AI minus 1 to BI minus 1 with shift by I. And so, so theorem in my local system of categories, if I have two alcoves connected by a wall, maybe by a face, maybe of symmetric with respect to a face of possibly hyperdimension, and then I can still go around this face and get from A to A prime. That the equivalence induced by such a path A to dB of A prime is a perverse equivalence where the perversity function is governed, comes from the central charge polynomial. So this is essentially, yeah, okay, I'll say what this means in a bit more detail, but this is essentially follows from, well, it was conjectured and proved for codimension 1 faces in a paper with Anno and Mirkovich, and in much more interesting case of arbitrary codimension follows from our paper with Losev. So basically, I'm saying that there is a map from V, polynomial map, zeta, from V to R to the dual space of the K group, now not graded. And so tensor with R, and let's say we take sheaf supported on the preimage of the central fiber. So this can be thought of as a flat section of the degenerate of the connection coming from the non-graded K group, where singularities on the devices basically disappears. But okay, anyway, so there's some elementary map. Essentially, if lambda is a class of a line bundle, then it goes to the functional which sends f to the Euler characteristic of f tensor of lambda. But it has the key property that a point in an L curve is positive is not equal to 0, then zeta of x paired with a class of M is more than 0. So this is a key property I can show. And then for a phase, there is a filtration by the order of vanishing at this, as you approach this phase, gives a, so AI consists of all M such that psi of X M vanishes at order at least I on this phase bounding the L curve. So this is some partly inspired by the theory of bridge stability conditions, but it's well then this is one aspect of this picture, and another aspect is relation to stable envelopes. So let me only state this. So assume we have an Hamiltonian torus sector with finitely many fixed points, which is, of course, the case if it's G mod P. Let's see. Acts on X, preserving the symplectic form, commuting the gem action with finitely many fixed points. And then Okrenkov and his collaborators defined so-called stable envelopes in the Grothendieck group of well, C times star X. So it's some class of an object supported on the attracting variety. So there's an index by fixed points and supported on the union of attracting varieties of various fixed points for a fixed co-character of C. But so this depends on a parameter theta, which essentially runs in our space U tilde, real points. And so I have another claim that basically if I go from xc to xc prime through A, so the point is that maybe I didn't emphasize this, but there is a canonical homotopic path in logarithmic ordinance, just a straight path connecting this point C to A, and then I can go from xc prime this way. Then it's kind of sends so this equivalence sends stable envelopes for parameter theta in A on xc to those on xc prime. So that's the way it characterizes this equivalences. By a theorem, by a result of Su, Zhao, and Zhang, so maybe let me here assume that X is T star G B. So these stable envelopes, they correspond to classes of objects which correspond to Verma modules under the derived localization in positive characteristic, which well, I didn't address explicitly, but which is in the background of all this. Okay, so I should end soon, but so let me end with conjecture that the above generalizes to any symplectic resolutions X to Y. And for quiver varieties, well, maybe with some assumptions, many quiver varieties. Part of it is a theorem being written down with Okrenkov, namely, so we didn't get to this Perelos equivalences business, unfortunately, but the local system with the above relation, local system of categories related as above, to quantum cohomology and stable envelopes. So this is a theorem in progress with Okrenkov. Okay, so I think I should stop here. There are various aspects, I mean, various conjectures and results relating it to other things. In particular, there is just in some cases, there is a realization of this in terms of mere dual family, or conjectural and partly known relation of this to the mere dual family, and to Shibboleth loop spaces. But let me stop here. And also, let me just stop with, finish with, again, emphasizing that much of it is not new, but I chose to talk about this again. So hopefully I'm hoping to get more people interested and get involved into this program. Thank you.
Thank you very much, Roman. Are there questions or comments? So I missed a little bit the role of this toric variety that you introduced reasonably early on.
Yes. Well, in a way, this is a yes. Oftentimes, I present this data in terms of this W tilde equivariant local system on the complement to affine hyperplanes. But from some perspective, I think its nature to portion by the lattice and get this data on the torus, and then so this homotopy in this logarithmic coordinates, homotopy points near the points in the compactification are these imaginary cones. So remark and neighborhood of xc is that of x to pi I. Well, lambda, where lambda is in VR plus I C, something like this. Yes, but this toric variety is, I think, more natural from the perspective of quantum cohomology and perhaps like mirror dual family. So, yeah, the mirror dual family is, say, for T star G mod B is expected to be this family of parameterized by regular semi-simple conjugacy classes in the dual group. So let me see this. Conjecture. So it's two star G mod B, at least in the sense is well, X S, which is D of S intersect with BL plus BL minus. So where this is so S is a regular semi-simple. So the match is basically a Gaussian decomposition lying in a given semi-simple conjugacy class. And so because the affine while group can be realized as orbital fundamental group of the set of regular semi-simple conjugacy classes in the dual group. And yeah, so I think this filtrations that I entered this discussion of perverse equivalences, they are related to limiting Hodge structures in this family. But we can discuss this later.
Are there further questions? So I posted in the chat a link to GatherTown. So at any time during this workshop, if you would like to chat with someone, that's available. So perhaps we could go there to continue discussions. And then we meet back here at in 20 minutes time for Tony's talk. So let's thank Roman again.